Hi guys, Luke here from Flukes Kitesurfing. Welcome to today's video. In this video, we're going to be building the fuselage for our hydrofoil. So I'll be following the plans. If you don't already have the plans, you can download them from our website, but it has a lot of the different dimensions that we need. And we'll be building a fuselage very similar to this one. So sort of a shaped, solid, extruded aluminium bar that has screws, so threaded screw holes to connect the front wing, a socket connection for the mast with the screws in the bottom there, and also threaded screws for the rear wing, and then sort of a shaped and sanded finish. This is about 2 years old now, this fuselage. It's held up really well. Lots of bangs, scrapes and things like that, but just a quick sand of this would bring it up to an as new condition. So I'm really happy with the performance of this fuselage. No twists or bends or anything major, and so all the threads are still good, and so I'm really happy with this component. So in this video we're going to start with a solid square. This is 1 inch by 1 inch or 25mm by 25mm extruded aluminium bar, 670 millimeters long, and then we'll start by drilling all of the holes that we need, so for the front wing, the rear wing, and for the mast connection point. Then we'll route out and machine out our mast connection socket. Then we'll do our basic shaping, so sort of cut in all the main shaping that we want done. Then we'll tap all of the threads into where the wings are going to connect, and then we'll go back to our final sanding and clean it up, and we'll have a fuselage. So let's get into it. So I've cut the fuselage to length. Next step is to drill the holes. For the holes for the rear wing and for the front wing, we'll drill a 5mm hole, which works perfectly for the M6 thread that we'll tap in a future step. And then for where the mast connects, for my mast, which uses M6 bolts, I'll be drilling a 6.5mm hole, which gives that 0.5mm tolerance, which is exactly what we need in order to easily put the thing together when we're using it. What we do is we measure in from either end, just using the measurements that I have. You might need to modify the measurements for the mast connection if you're not using a Flukes kitesurfing mast. If you're using a different mast, measure the distance for your holes in order to modify that for whatever works with your mast. And one other important point is when you're drilling, I'll be using this drill press, which I've set up with a guide which holds that piece of aluminium right in the center, so I know I'm drilling straight down the middle. That's the best way to do it. But if you don't have a drill press and you're going to free drill it, you can still free drill it, but either way, even with a drill press, what we want to do is make sure that we are marking right on the connection point for whatever it's connecting to. So for the rear wing, we want to drill from the underside, so we want to mark it here and drill it so that when the wing connects, we know that that point is perfect. Even if the drill bit sort of tilts and comes out exits from the sort of a tilted angle, we know that where it's connecting to the wing is perfect. So I'll be drilling from the underside for the rear wing and for the mast connection, and from the top side for the front wing. So in order to do that, first thing we want to do, of course, is mark our fuselage so that we know that that's the top, so that we don't get it all mixed up while we're about to start drilling. Just using a scribe. You can use a pencil here, but a good way to mark aluminium is to scratch it. We're coming forward on the plans 35mm and 65mm, and then square them across. And then you can mark the center particularly if you're going to be hand drilling them, but with the drill press that I'm using, because I've set the center, I'm just going to drill straight in there. So then on the same, we're also doing the bottom side of the mast, so I'll come from the nose Okay, so I've set the drill press up so it's perfectly in the center of the fuselage. I haven't center punched it because I prefer just to set it up and let the drill sort of find its seat, but I do like to clamp every location. So I'll start with the rear wing and bring the drill press down, line it up perfectly, that, clamp it on, and we are ready to drill. Nice, look a little dry, just give it some WD-40. And there we go. The first hole is drilled. So I'll repeat the process for the holes on the front wing and the rear wing. So now I've finished drilling the holes. So we have our through holes for the wing connection. They're 5mm holes that we'll tap with our M6 tap. And we have the through holes for the bolt connection to the mast at 6.5mm. The next step is to route out or machine out our socket connection for the mast. So something along the lines of this, and I thought I would just quickly explain how I did this so that you can do it for your mast or for the Flukes mast. It took me a little while to sort of work out exactly how I should do it in a DIY sense. Of course, ultimately we would have a CNC cutter, and the CNC, you know, would just cut it absolutely perfectly. That's how they're created in a factory. But at home, with minimal tools, I thought, you know, how can I do this? And so I just wanted to explain how I did it. So like I said, you can try it for yourself on your mast or on a Flukes kitesurfing mast. So you start with the base plate. The base plate, of course, is the exact shape that we want in the fuselage as well. It's made for the mast. You can see that with this design, it has a straight cut. You can see how there's sort of the tail and the nose has a straight cut going all the way through it, and then it has sort of the foil shape of the mast. And so what I wanted to do was just create this in a flush trim jig right here using some acrylic, and then with that jig place it on the fuselage like so, clamp it in position, and then machine out that same socket. And so the way that I created this was I first started by routing out a slot, so a straight line to the right length, and then I fastened this in position with some clamps and some wood so that it was sort of underneath that, so it's pressed up against the acrylic. And then used a flush trim router bit once I had my slot to just go around and machine out the rest of that shape. Of course, it's important that the bearing only just sits within the top of that, so you don't damage your base plate while you're doing it. But that way we got exactly the same shape across onto the acrylic. So then we do the same thing in reverse with the top bearing router bit, so that now when this is clamped onto the fuselage, I can drop this router bit down, the bearing runs on the acrylic, and the cutter of course goes down into the aluminium. It's reasonably heavy work, and so you have to do it like 1 millimeter at a time. We're going down 15 millimeters, which means it was 15 passes, setting the router bit every single time, going down slowly, 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 just taking it out. It's, like I said, it is kind of heavy work for the trimmer router, and so the best move really is to actually pre-drill a lot of it out. So that's what I'm about to do now. So the first step will be to use a drill bit. Of course, we don't want to go outside the parameter of what we want to our finish shape, but to come and just remove most of the material with the drill. It's a lot easier with the drill press than it is with the router. And then we'll just sort of clean up that shape with the router bit. Let's do it. Of course, we want to be routing out from the top. So in simple terms, we're going to be coming back from the front of the fuselage to the front of where my mast slot will be. So marking the front and the back of the mast. The next step is using the jig to try and just mark out the rough shape that we need. So getting that in position there so that we don't drill outside the line while we're removing some of this material. So now I've put the 5 millimeter drill back in, and I'm going to use the 5 millimeter drill to drill out where the slot is. We're using a 6.5 millimeter or 1/4 inch router bit to actually route that out, but the 5 millimeter will remove most of it. If you use a 1/4 inch drill bit now, which we could do, you run the risk of just being slightly off center, and then when the router goes through, you end up sort of with this jagged line. So better just to use something a little bit smaller and then clean it up when we use the router bit. So the first step here is to actually bring it down to 15 millimeters. Okay, so now with the drill press depth set, I can start removing some of this material. I'm going to start right on the edge, right to the line. Alright, so now I've removed most of the material on the drill press. The main thing is that you stay within the lines, but I actually went a little close on the trailing edge there. That last hole could be a little close to the edge, so hopefully that cleans up okay. So the next step is to route out the flush trim template. Okay, so the way I like to do it is start by just screwing a mast on. I've got a short mast here, makes it easy, but any length mast will be fine. And so I'm with the mast screwed in position, but not super tight, so it can still move with the template. You can then slide down the template straight over the top of the mast. Should fit absolutely perfectly. And down onto the aluminium. What that will do is it will give us, there we go, our front to back to position that it's absolutely spot on. So we know when we put those bolts in, the mast is going to be perfectly aligned with our socket connection. So now we can clamp the template in position and we can remove the mast. And we'll just carefully position this back on the bench. Readjust this one to underneath. And there we go. So now that is completely in position. And I can actually see that it's slightly off the mark that I made. So that's why I like to make sure it's right with the screws and not just rely on the measurement for this, because it has to be just so spot on. Alright, let's set up for routing. Okay, so I've set up the router and you can see I've just put the bearing just down from the plate there, so we'll be doing our minimum cut on the first one, which will be about 2 millimeters in. Then we'll go 1 millimeter at a time as we go down and down. Now this is a 9 millimeter or 3/8 router bit. And so it won't go all the way into the track. So because the flat section is only 6.5 millimeters, it'll stop before it gets to there. So then we'll switch out into a 1/4 inch router bit and finish that off. So first step, we're going to go all the way down, so all the way down to 15 millimeters, 1 millimeter at a time with the 3/8 router bit, and just slowly go round and round, taking it out. So let's do it. So most of the bulk is taken out now. If we look in there, I've taken it down to 15 millimeters, and you can see it's just the two sort of straight tabs that still need to be machined out. And there's a couple of ways that we can do that. If we had a 1/4 inch flush trim router bit with a top ball bearing like the other one, but a 1/4 inch like this, that would be really good. I actually bought one. They're sort of a specialized router bit, and they've got a small ball bearing there the same size as the 1/4 inch, but the problem is by the time they put the ball bearing on, it makes it very thin and very fragile for the shank, and so it honestly ran for about 10 minutes before it snapped. For aluminium anyway, it's a light duty router bit. So the workaround, or another way you can do it, is just using this straight cutter and either setting up a fence, right? So taking the jig off, putting a fence on your router, and then just running a straight line. I'll just hold that straight through there and just run a straight line. That would take most of that out. Or you can use the shank of the router bit to rub on the acrylic and act like a ball bearing. That is like not recommended. What it basically acts like, if you can imagine, the shank is the same width as the cutter, and so it acts like the ball bearing is seized, and so it does crazy things like burns, and it's not ideal. But that is how I did it last time in the end, and it does work, and so I'm going to do that again. But what I like to do now is just spray it with WD-40 and just very lightly take small amounts out of the two tabs and let that shank just run on the acrylic. So that's what I'm going to do. Also, I'm just probably going to do a little bit more drilling. The 5mm drill looks really neatly in the center of the template, so I'm going to go down with a 1/4 inch drill bit so that it's the same size as the router bit, and just sort of take a little bit more material out of there so that it takes a bit of pressure off this router bit. So I'm setting the router bit to the finished height, so you can just start to see that it's just hitting on the bottom there, so it's all the same height. And then that way it's just one pass, and we just very slowly try and remove the last bits of that material. It's a bit of a wild ride, but it does work. Lots of oil or WD-40 is definitely a must. Alright, so I've taken that out now, and you can see that's pretty well machined all through the bottom. The moment of truth, and let's see if the mast fits in. So I've got the mast that I normally ride with, so I want to check that and make sure it's going to go in. Oh, there we go. Perfect. Okay, and that is done. So close-up look there at the socket connection. Obviously not as good as what a CNC machine would do, not as neat, but still effective. A great sort of solid connection now between the mast and the fuselage. You can see a really nice snug fit that's going to reduce that lateral shaking or any movement. So that is the socket connection done, and now let's move on to shaping. So now it's time to shape the fuselage. The goal here is to slim out the fuselage. You can see it's slimming out through the tail there and through the nose to reduce weight and also increase hydrodynamic efficiency and reduce drag in the tail. So we're just trying to slim it out and make it more, hydrodynamic. The way that we do it, really simple jig. We cut it on a table saw, so a regular table saw, but you could cut it with any saw that, a jigsaw, a bandsaw, whatever you have handy. But the table saw is a really nice way to do it because you can create a parallel jig like this one and then fix the fuselage in position like that, and then you can see it trims off whatever is on the other side of this. So you set the fence here and the saw will just trim whatever is exposed. And so on the new fuselage, you can see it will trim that off on that angle. The angle is not super critical. It's just something that works and looks like it's going to slim it out. So you can see that's what it will be taking off, right? You could make any angle that you like. You can lay the fuselage on and set it up, fix this block into position, and then run it through the saw. The other two angles, which are the front angle underneath the front wing and these off the trailing edge of the fuselage there, they're the same angle. So once I set this, you can see this line here, once I set the block to that angle, then it will actually run both this one, if that makes sense. Flip it, it'll cut that, and it'll cut this. So the way that we fix it into position is, I've just got this sort of small clamp, screw clamp, so you just screw that down, it sort of pinches it into position. We can also screw through this socket connection directly into the block here, but anything that you need to do in order to fix it into position. Last time I ran it in a pass, when I was building this one, I ran it in one pass, and somebody commented, oh, I ran it in multiple passes. It makes so much sense. I can't believe that I tried to just push it through the single pass. But so what you do is you sort of set the saw, just taking it 5 mils at a time and just keep coming up until it's gone, and that is a lot easier on the tools. So look, that's it. So we'll just set it up. Like I said, the dimensions, you can you work off the plan, or you can make your own dimensions, just make something that looks and feels good. This angle sort of comes to the back of the front wing. On the plan, it's sort of drawn to 95 millimeters, but I think that's about 130 millimeters by the time it's down there. The only one consideration is the thickness here. So you want to make sure there's enough thickness under the front screw. So we'll be cutting this off. So we need to leave enough thickness here to make sure we could like screw in through the top of the front wing and into that piece of aluminium. We want it thin enough that it's a nice smooth hydrodynamic flow of the water going underneath the wing, but thick enough that we're getting enough purchase with the screw. That's really the only key thing that we're trying to pay attention to. The rest of it is just about, like I said, slimming it out, reducing weight and reducing drag. The one last thing I should mention is make sure you're cutting it off the right side. So with the hydrofoil, if you remember from the planning, we have the rear wing here on the bottom side, the underside of the fuselage, and the front wing on the top side of the fuselage, right? So we're cutting underneath the top wing and off the top of the fuselage here, so the rear wing still has that flat surface underneath it. So really important not to accidentally cut off the bottom of the fuselage here, because we need those angles to stay correct. Okay, now we're ready to go. Okay, so I've finished the rough shaping of the fuselage. So slimming out into the nose, you can see the angle we have there, leaving around about 6 millimeters in the absolute front. And also slimming out into the tail, bringing it down to around about 12 millimeters, and also sort of bringing the back to a point as well, just to reduce that drag and reduce weight like we're talking about. Once I'd cut that on the table saw, it leaves some sort of saw marks, and so using the belt sander clamped to a bench, I've just cleaned all of that up with some 60 grit sandpaper, and also sort of pivoting on any of the areas that has that hard edge and just sort of blending that together so it looks nice and neat. Done that on all of those surfaces, and then once that was looking good, I switch out to 120 grit sandpaper, go over the whole thing again just to make that neat. One thing we're paying attention to is not sanding the areas where the wing is going to attach to there, and not sanding the area on the bottom where the wing is attaching there, because we don't want to create a round accidentally. So just sort of cleaning up all the areas that we'll cut in. Okay, so that is it for the rough shaping. Now let's move on to the final shaping. And what we'll be doing is softening the edges. So using a router, this is a 1/4 inch round over router bit, just a pencil round. It could be 5 millimeters, 6 millimeters, it doesn't really matter. But what I've got is the router set a little low, so you might not be able to see that, but it doesn't take the full cut. It's just sort of, you know, partial cut. And the way that that looks on the fuselage is, you can see, sort of has that somewhat hard edge, if that shows up in the light. So it's soft on the edge, and it just creates this line on the top. I do that for a couple of reasons. When you're going over a curve, if you try and take a full depth cut, it'll gouge out a little more when you hit those curves, and it makes it sort of harder to sand. And also, where we're getting close to the socket connection, a full 1/4 inch router bit would actually sort of just hit that inside corner, and so I want to leave just a slight bit of thickness there. I also work from the top and the bottom surface, so not from the sides, and it's for that exact same reason, so I can stop the router depth and have that line there instead of taking the full depth and running the bearing into the socket connection, running the bearing potentially into all of the screw holes. So I sort of put the base plate on the top and on the bottom, and that's how I like to run the router. As well as that, very important not to go too close to the nose here. So you can see what I've done is I've just marked on the fuselage, do not route this section, right? It's very easy to forget that you want to stop there. And that distance is 150 millimeters back from the nose. And the reason I'm doing that is that sits back a little bit, but this way, if I want to make wider wings, 180, 190 millimeter wide wings, and pull the trailing edge of the wing closer to the mast connection, then I've still sort of got a nice flat surface the whole way there. We're doing the same thing on the bottom surface for the rear wing. So that is 80 millimeters from the trailing edge, and I'm just going to stop there as well. For this step, like I said, I just use the router bit, spray it down with a little bit of WD-40 as usual, and just take it nice and slow. So let's get into it. Okay, and that is the routing done. So you can see we've just softened those edges all the way around, leaving the flat sections for where the wing connects. And at this point, I just leave it like this. So you can see it's not completely smooth yet. You might be able to see a couple of little ripples there in the light. And so we'll smooth that off with sandpaper in a moment. But what I like to do now is move to the rest of our machining. So tapping our threads, doing our countersinks, and getting all the machining done. And then we'll come back and we'll fine sand it just to clean everything up. That at the same time, we can sort of hit any of these corners and anything like that. But that routing is just a nice way to soften those edges, reduce some weight without reducing any strength. And just in case you kick it and things like that, a bit more, a bit softer. So like I said, the next step is going to be tap the threads. So tapping the threads, I use an M6 metric 6 tap I've got set up here. So you can see this is for an M6 screw. That's the standard screw that I use, but of course if you have a different type of screw you'll need a different tap. And it's a pretty simple process if you haven't done it before, so I can just take you through it. When you're tapping your thread, you want to start on the surface that is going to connect to the wing, so where the screw is going to enter, that's the side we want to work from. And we also want to make sure that everything is really plumb, straight up and down, so we don't create threads that are on an angle. I just use WD-40 for this. Clean out that hole, and then, you know, I find this works. Of course, there is proper professional tapping grease that is preferred, but like I said, I just use WD-40. And the main thing here is, like I said, to keep it plumb as we're going in. So I just give it a few twists, applying a little bit of downward pressure so that it doesn't strip, but we're just twisting in while it's starting to bite and create that first thread. And then once you start to see a little bit of resistance, you go back sort of half a turn, that snaps off any burr, and then go back down another turn, and then back half a turn. You just continue this process all the way down, again just making sure you're nice and plumb. It's really quite a simple way to get a thread in the aluminium. It's nice and soft. A little more oil. One of the reasons I like to do the shaping first before you tap the threads is that, of course, we've slimmed off so much of the material, you don't have to tap all the way through the full 25 millimeters. And then eventually it will start to come out the other end, and you'll just be able to spin it. And then once it's fully clear, you can reverse it out. Reversing it out, you want to keep centered. So the reason I'm spinning it on here is I'm not trying to add too much pressure on the outer sides. And then with some fingers underneath it, just a little bit of upward pressure so that it doesn't create a new track or anything like that on the way out. Okay, and there we have it. Blow any bits out, and there we go. The first thread is cut, if you can see the thread in there. So before we wind a screw into that, we'll just gently countersink this to let the screw seat in nicely. But that is it, and let's repeat the process for the rest of them. Now we're ready to countersink the holes. I like to use this router bit. This is just a pointy 1/4 inch router bit, but it has the perfect pitch for the screw head. But you could of course get a countersinking bit. Sort of needs to be specialized enough that it can do aluminium though, because a lot of the wood bits struggle with it. And I'm going to come and set the heads down until they're flush for the 3 points where it joins to the mast, and then just lightly touch the rest of the holes so that we just take any burr off the sort of right off the edge, and it allows that screw to sort of more easily find the thread. So let's do it. So with the countersinking done, it's now ready to fine sand, finish sand. So I'll use the random orbital just to go over all the curved surfaces, and the belt sander now just to sort of finish shaping any areas that really need still some to be taken off. You could hit this with a file as well first, and then just use the random orbital sander. So now that is all sanded up, I hit those corners and just tidied up any of these details that I couldn't quite hit with the router around the front wing and the rear wing with the belt sander, just sort of reshaping some of that. And then using the random orbital, just went over everything, softened all of those edges, starting with 80 grit on the random orbital and then finishing with 220 grit. And the 220 really gives it this sort of polished look. You can see the sheen that it's got on it, and that's a finished product. I mean, that is ready to hit the water. You could now sand it lengthways with some wet and dry. That's really nice. It gives it that sort of grain look, the same as the aluminium, as it's extruded aluminium, sort of does have that lengthways grain. But to me, this is a finished product ready to go. The other option would be to now paint it. So painting it in a black or something like that, it would look pretty sharp. The advantage to painting it is that you don't get that oxidization that you get on aluminium. So here you can see this oxidization on this flat surface, and so it would be nice not to have that. But like I said, this is like 2 years old, so that's a long time, and it would only be a 10-minute job to sand this back up to look exactly like this again, right? The disadvantage to painting, and the reason that I don't normally paint, is that I'm pretty hard on my equipment, so this is going to get hit, it's going to get scratched and dinged, and then it kind of starts looking worse than if you didn't paint it at all. So I kind of like the idea of just being able to quickly retouch it up and bring it right back up to its standard without having to then sand it all back, prep it, repaint it and things like that. So I like the aluminium look, but it's really a matter of preference. And there we have it. A completed hydrofoil fuselage. I really like this component. It's strong and durable and modular. It will fit with a variety of different wings that you might want to make, a combination between front and rear wings, and also a stable socket connection to fit the mast of your choice. So hopefully that video was helpful. That is it for this video. Luke here again with you from Flukes Kitesurfing, and we'll continue building our hydrofoil in the next video, so I hope to see you there.